Yeah, science!
I love science, ever since I was a kid. Now, you may be thinking, Wuten, what the hell does science have to do with ponies? I mean, aside from Twilight's nerdiness, we don't really see much in the way of that sort of thing. Well, I'm here to show you something that may or may not have been started as a Skype chat conversation.
That's right. If the princess has moved the sun and the moon, does that mean that the sun is just a small star about the size of the moon?
Great question, but I have one better. If that's the case, and the moon really is the same size as the sun, how much energy would it have taken the elements of harmony to send Luna to the moon?
GI's moving.
Because we're doing this at the drop of a hat, and neither you nor us have the production value to make a bunch of vectors for a short video like this one.
Moving on. So that would mean the sun would have to be pretty small then, right?
Right. There are actually some stars that are small enough. White dwarf stars are about the size of the Earth on average, and neutron stars are even smaller than that.
Yeah, problem is, the gravity would crush the planet before it even came into existence.
Right. Okay, so that's out of the picture. So Equestria has a normal sun. What about Nightmare Moon and the elements? How powerful are they to be able to send her rocketing towards the moon?
And that, my friend, is where math is involved.
Oh boy.
I'll take it from here. So, the typical measurement of energy is in joules. In this case, a single joule would be the amount of energy it takes to lift an apple, approximately 100 grams, 1 meter into the air.
Right. So for this, let's assume the distance between the planet and the moon is the same as the distance between Earth and our own moon, which is about 384,000 kilometers.
And ponies are pretty small, but Celestia and Luna seem to be the size of regular horses, which would probably weigh anywhere from 380 to 550 kilograms. Luna's not quite as large as Celestia, so let's put her on the smaller end. Does 450 sound good?
Perfect! So if we normalize everything, including gravity, how much energy does it take to move an object that is 450 kilograms, a distance of 384,000 kilometers upward? With gravity, which pulls an object downward at approximately 9.8 meters per second squared on the surface, decreasing by 1 over r squared, acting upon it.
Right, but how much time would it take?
Who knows? Wuten put the clip into Adobe Premiere at 60 FPS. Wuten found the time it took.
Great! So how much time did it take?
Exactly 3.083 seconds.
That's fast.
Yep, Luna be liquefied before she even reached the atmosphere.
Wuten, you know what that means, right? 3 seconds to the moon?
2 seconds to Mars.
No, she was traveling exactly at the speed of light. 1.5 seconds there, and 1.5 seconds for the light to reach back to the planet.
Well, looks like I don't have to calculate to tack onto that one.
This could also explain Twilight's teleportation spell. Unicorn magic can change the state of matter to energy and back for brief periods, this just being on a much more massive scale.
I don't feel all that complex when I do it.
Where did you get that?
I found it.
Show off.
Back to the equation.
Right, so 3 seconds to the moon. That means she's traveling roughly the speed of light, which takes 1.3 seconds to travel to the moon and 1.3 seconds for light to travel back to the planet. But how much energy would it take to do that?
Well, the equation to calculate energy for that has already been made for us, actually. Since we have the weight of the object, the time it takes, and the distance traveled, let's do some math.
But that's when she's accelerating. When you're moving at the speed of light, you're technically not moving, so therefore not accelerating.
Ah, but she's traveling almost at the speed of light, so she is still accelerating. 2.6 seconds is not 3 seconds quite yet.
Oh, good point! And Einstein already gave us an equation for that.
Right. E squared equals mc squared quantity squared plus pc quantity squared.
This is getting too big even for me.
It's not so bad. We already have most of everything we need. Just plug in the numbers and call it good.
M is Luna's stationary mass, which we've already calculated to be 450 kilograms. C is the speed of light, which is 299,792,458 meters per second. Really damn fast. And P is the relativistic momentum, which is important because in relativity, your mass increases as you approach the speed of light.
Looks like eating a bunch of cakes isn't the only way to get fat.
So, we get P is equal to mv over the square root of 1 minus v squared over c squared, where m is her stationary mass, v is her velocity, and c is the speed of light. Since Luna is getting to the moon in 1.5 seconds, she's traveling about 85% the speed of light. So, if we plug in those numbers, the energy required is about a fuck ton.
Oh, but that's not all.
Calculator.
Not only is there a huge amount of energy to get her to the moon, but do you see that there? From the looks of things, it looks like that spell completely disassociated her form at the molecular level. So not only did the elements send her to the moon, but the ceiling inside it, the elements disassociated her at the molecular level to become the mare in the moon.
Shall we put a number to that feeling?
About 76.7 exajoules, which is the equivalent of an 18.3 gigaton nuclear bomb.
Great Scott.
That's a fucking huge number.
Couldn't just smushing her to a pulp on the moon have the same effect?
Not quite. How would she come back after 1,000 years?
So what you're saying is, the elements of harmony managed to, without liquefying her organs mid-travel, send a horse to the moon at 85% the speed of light and not blow up the moon in the process, and then, using the energy from that travel, managed to dissociate her at the atomic level to seal her inside the moon.
Pretty much, yeah.
GG Novri Magic OP, please nerf.
Science, bitches.